All right, now we're going to take everything that we know about the graphs of sine and cosine and use that to find the formula of a transformation of a graph. All right, so I have down the bottom right the three transformations that we know how to track on a sine or cosine function. The A for the amplitude, B changing the period, and D changing the midline. Again, it is possible to have a horizontal shift, but there's so much interplay with the B and the C that we're going to skip those horizontal shifts. So that's going to help us when we find these formulas today. All right, so let's take a look at this graph here. We want to focus in on one period of the function. So you could focus in on any period of the function. So for example, I could go from this maximum spot here until I get to the next maximum spot. Okay, so any repeat of that graph. I could also go from this midline intercept until it finishes one wave. Okay. So I could consider this one period of the function. I could also think of from this trough over here to the trough over here. All right, the easiest kind of period to focus in on is going to be one that starts off on the y-axis. And since I told you I'm not going to give you any that have a horizontal shift to it, this is usually going to be your best bet. All right, so I'm going to focus in on the period. It starts off at 0, 2 and then finishes up at 2 pi, 2. All right, so that looks like a sine function. Remember that sine normally starts off at the origin, but at its midline goes up, down, and then hits the midline again. So I'm going to write this one as a sine function. All right, let's do the easy part first. Let's find the midline. The midline of this graph, the horizontal middle. Let's see, I'm going to draw this with my red pen. That looks like it's at y equals 2. Okay, so my midline is at 2. My amplitude, let's see, that's the distance from a peak to the midline or from the midline to a trough. That's 1 tick mark. So my amplitude is equal to 1. And then I also want to talk about the period. And the period of my function is how long that one cycle that I highlighted goes for. All right, and that looks like it's going to be a distance of 2 pi. All right, so the midline and the amplitude are pretty straightforward. We're just going to plug those in for A and D. The period is the hard part. So remember that our formula for the period is equal to 2 pi over B. All right, and the only way that that works out is if that B is equal to 1, right? So let's see, B is equal to 1. So let's write down our sine function. We have y equals A, our amplitude is a 1, so you can write a 1 there, or you can just kind of let it be understood as a 1 coefficient. I just figured out my B should be equal to 1, so that's just going to be bx. And then the D is plus 2. And again, I'm ignoring that C because I'm not going to give you any graphs of functions that have been shifted right to left. All right, so we can just kind of leave those out of our answers. Next up, let's look at this one. All right, so we need to focus in on one period of the graph. And let's see, I told you I'm not going to give you any that are shifted left to right. So let's just focus in on where it starts at the y-axis. So I'm going to highlight this period. And once I get back to that same spot in the wave, I'm going to stop, right? And that doesn't necessarily look exactly like a sine or a cosine. Remember, sine, before you transform it, looks like this. And cosine starts off at its maximum. Okay, so it definitely doesn't look like a sine to me. What it looks like is a cosine that's been flipped upside down, all right? So a negative cosine graph. So that's how we're going to work this one. This is going to be a negative cosine. All right, let's focus in all those transformations that we know. First, the midline. The midline looks like it's here at 0.5. So we'll say our midline is y equals 0.5 or y equals a half. And then our amplitude, the amplitude is the distance from the midline to the peak or the midline to the trough. And that looks like, well, that's going from 0.5 to 1 and from 0.5 to 0. So that also is equal to a half. And then the period is the horizontal distance it takes to complete one cycle. And that looks like it's equal to 2 pi, 0 to 2 pi. Okay, and again, that we have to kind of reverse engineer what the B must be. And this one's going to be the same as the last one. We know our formula is 2 pi divided by b, so this must be b equals 1. So let's put that together in our formula. Y equals, I need to have a 1/2 out front for the amplitude, but we said this was going to be a negative cosine shape. So I'm going to do a negative 1/2 cosine. B is 1, so 1x. Ignore the c for the horizontal shift, and then add on your midline, which we said was a positive 1/2. All right, let's try one more. All right, first step, we're always going to identify what period of the function we're looking at. And I'm going to start off on the y-axis. That's going to be our easiest thing. Let's see, it started at a y-coordinate of -1, so I'm going to stop when I get back to that -1 spot. All right, so there's our 1 period. And let's see, since it's starting off at its midline and going up, this looks exactly like a sine shape. So we're going to graph this as a sine function. Let's identify our midline. We started at -1 and ended up there. That looks like the middle point of the graph. So our midline is y equals -1. That's going to be our d value. Amplitude, we want to measure from a maximum down to the midline, or from the midline to a minimum. All right, and that looks like we're going from -1 to 2, that's 3 tick marks, or from -1 down to -4, still 3 tick marks. So our amplitude is equal to 3. For our period, how long does this take to complete that purple cycle that we highlighted? Okay, this time it's only going to pi before it starts to repeat itself. So our period is pi. And remember that we have to figure out what b value is going to make that work. Okay, 2 pi over b. All right, that must be 2 pi over 2, right, in order for it to be equal to pi. So our b value this time is equal to 2. All right, so let's put all of that together. We have a positive sine graph with an amplitude of 3. So we're going to do 3 times sine. Bx, our b this time is 2, so 2x. And then plus d plus a -1 is going to be -1. All right. The nice thing about these problems, you can always hop over to Desmos and graph these and see if you got the right thing.